All right, guys. I'm not here today, so we're gonna cover. It's not eraser. We're gonna cover tomorrow's notes today on a video, so we'll be all right. This is on page 608 to 611. 611 has your calculator stuff. So we're gonna be tackling confidence intervals today. Difference of two proportions. So we're still dealing with p hat 1 minus p hat 2. The difference is that the standard error and the standard deviation look a little different. Remember, the standard deviation is the population, the standard error comes from the sample. But why is it different than the significance test? In the significance test, we pooled the data. So here we are not going to combine. So do not combine. So we will not use, so this is piece, the probability of the combined is not going to be done. Why? We're not assuming there is no difference. So if we talked about it yesterday, the reason we did this is we were assuming in H of O that P1 equals P2. That is not happening here in our confidence intervals. So it basically becomes that big equation of p hat 1 times 1 minus p hat 1 all over n1 plus. So we treat them separately like we originally did. Remember, the only time we're going to pool them is in that proportion for a significance test. So this is our standard error idea for our confidence intervals. So we're still back to confidence intervals. So back to state plan do conclude. Don't forget the formula is not on there. It's as always, it's not on there. Just the basic formula, which is point estimate plus or minus critical value times our standard error. Okay, so that's the formula they give you. Our point estimate now will be P1 minus P2. Critical value is still going to be the same thing. It's going to be our critical value for a z-score because we're dealing with proportions. And then our standard error is going to take this equation from up here, and it's going to go there. Okay? So make sure we kind of understand those pieces. It's kind of like a rehash of everything we started a long time ago. What are the conditions for calculating a two-sample z-interval? Guess what? Random, normal, independent. Random, normal, those don't change. We still got to deal with, p hat 1 times n is greater than or equal to 10. 10. And then p hat, then n times 1 minus p hat 1 is greater than or equal to 10. And then dot, 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 dot. We need to do it for p hat 2 also. So we check that. So the only trick to kind of paying attention to these, and it's really not, sometimes it comes up where it's one population and they take a sample and then they split it. It's okay. So it happens a lot because you can't really always get two separate populations to sample from. So if it's one population and they split it into two samples, in other words, you get like, we get proportion 1 and proportion 2 from this population, it's still considered two independent samples. Okay, so we're still independent. Technically, what we're saying here is that this is the proportion from population 1 and this is the proportion from population 2. That doesn't always happen. It's always, it can be from one population and they're split into two different populations. And I'm doing that quotations in my fingers in front of you right now, and you just can't see it. Yes, it's definitely okay. In fact, I recommend doing the do step in chapter 10 because, as you can see, the formulas are massive. Just understand when you see it in the book, the x's must be integers. So, in other words, if I have 7 out of 22 shots made, when you put this into the calculator, you have to put 7 and 22. So x equals 7 and n equals 22. Do not use decimals. When you put the info in, it doesn't work. You'll see what I mean when you do that. So for the confidence interval, today I'd actually mess around with the calculator. For the confidence interval, the directions are on page 611. And for the significance test that we did yesterday, it's on 618. Now remember, you have to write out this. Go back here. You've got to write out this formula. So make sure that you label, and write out formula. That's the key to the calculator step. You can't just put into calculator. You got to actually do kind of label it and pull it together, okay? But then you can write all that. You can write like 0.47 minus 0.53 plus or minus 1.95 times, and then you can do the big thing like this, and then all you have to do is put an equal sign, and then it'll spit it out for you, okay? So you just got to put all this together, and then if you plug your stuff into the calculator into one of these pages, it'll just spit out the answer for you. It makes it a lot easier, and so we can work with it from there. So here's your alternate example. I'll kind of walk through it real quick, but it's all typed out for you guys, so you don't have to worry about me writing it and taking forever. So it's an old one. Remember, this book's old, so it's back when Obama was running for president, and so we've got different approval ratings. So the idea is you've got a couple of different things. We've done all these different explanations right here. And so for A, because it's 53% and 50% are figures, were from random samples, these are probably not equal to the true proportions of all of them, okay? And so that way we can actually get an estimate and see if they're in between there. So remember, we don't, just one sample doesn't give us the true proportion, so we got to find out where the true proportion is. So don't forget, we got our state. Don't forget to use context. They want a 90% confidence interval. And then we just label what everything is based on context, okay? So that's our key piece, is labeling everything on context. It's mostly writing. All right. So then when we get down here, what's our plan? We're going to use a 2-sample Z interval. Remember Z, we've got Zaptax. So we're here in proportion, not there. We've got Z and proportion, so Zap. And so therefore, we're going to test those conditions. It came from random data. We've got our test of these are all greater than 10. They're all greater than 10. And the sample was taken independently. There are definitely more than 10,000 adults in both 2009 and 2010. Notice we separated the two. Okay, that's what I mean. We got to split them into two, even though it's all from. These are two separate populations, but we got to test and make sure that we cover both of them. So make sure you cover both of them. You can plug this in, or just actually use your information from above, set it all up in the formula, and then you don't have to even do this part. That's if you use the calculator by hand. Let the calculator spit this out. So I would test these numbers using page 611. I would actually do this example using page 611 and follow through with it and make sure you get an interval close to this. Now remember, with that, you're going to use 512 out of 1,024. So you're going to use these numbers, not percentages, okay? So when you plug it into the calculator, use these numbers, not the percentages, and then that'll help you spit out your confidence interval. Then again, we're 90. I don't know why it. Hold on. There's an answer of 95%. What did I ask for? Did I mistype something here? I think I did. Oh no, construct a 90% confidence interval. Let's see if I did anything wrong here. Hold on. Oh, I did. This should say 90. We're 90% confident because that's a 90% one. We're 90% confident that the interval from blah, blah, blah to blah, blah, blah captures the true change in the proportion of U.S. adults from. So it is plausible that his job approval has fallen by up to 6.6%, or increased by up to 0.6%. So if you can look at this, it could have fallen 6.6%, or it could have increased 0.6%. And so the last question for you guys is, based on your interval, is there convincing evidence that his job approval rating has changed? No, since 0 is included, it's plausible there has been no change. Okay, so let's just say it was negative 6.6% to negative 1%. That means that 0 doesn't fall into it, and so there could be convincing evidence that his job approval rating changed. Okay, so that's kind of how you read that. There's our assignment for today, and we'll see you guys tomorrow. We are doing the weekly tomorrow. Good luck.